Hey, hi everyone. My name is Satej. I work in the role of a principal data engineer. Today we'll be talking about this very unique concept about how about enhancing retrieval augmented generation with multiple agent integration. So these are some of the content elements which we'll be talking about today. Starting with the general concept of retrieval augmented generation. If you all can see how, and I think most of you have an idea about the very general concept of retrieval augmented generation, but in essence, it contains two particular elements, that is your organizational data, which is present in an embedded database or a token-based system, where all of your organization important data related to documents, processes, business, etc., are stored in a document-based or embedded database, and which can be first layer where you are querying for. And once you have this information, this particular knowledge which you're feeding to a large language model to give you more kind of a natural language response back to your user. So that's what a very general retrieval augmented generation looks like. And the principal advantage of it is that it doesn't, remove hallucination, but it reduces hallucination, kind of mitigates it by limiting the response by giving a very customized prompt ensuring method along with the contextual data. So it limits the response to the contextual data of your organization to say. Now, RAG can be applied across many use cases. Some of the general are like summarization, conversational AI, question answering, and all of this are very specific if you're looking for a generalized model to answer questions specific to your business model or your organization. Now, when it comes to large language models and data querying and in general about generative AI, the key challenges remain still focused around the concept of hallucination, where how do we trust the data, about the data consistency and the timeliness of the data, whether the data which we have received is complete, because whenever you're fetching data from a particular context in the RAG module, uh, in the RAG framework, your data could be spread across different components, right? Different contextual area that could be around different documents. So the challenges lie across different, horizontal areas where not only you have to focus upon the particular document where your data is focused upon, but collect them and also verify how much, if you're not missing any data. And it also depends on the accuracy of your data, because all of these four elements are key to answer a particular question or to get into a solution mode to help your customers. And this is where I think the four concepts come together to solve this particular challenge. Is you have one is the large language model, which gives you the natural language response. The second is you have the embedded tokens or the values which store your organizational data. The third is how does the document relate to your metadata around your processes, your business. That is what graph databases bring the third dimension to this whole scenario. Along with the fourth is how do you bring algorithmic performance to search the very contextual data, which is performant, which is contextual, which is also relevant to the query. So these four aspects bring the four-dimensional aspect to this search-based contextual searching, which helps you answer the customer queries. Now, in general, this is what the RAG architecture looks with the graph concept right now. Now, if you see this picture here, the user questions, and we are now searching. Previously, the search was limited to the embedded data where it was tokenized. But now, if you see, there are two layers to searching it. The very first is we have another large language model which takes the question, converts it to a graph query, and we are searching it across a knowledge graph. And this knowledge graph gives you back, some more contextual data. This contextual data, along with the URL query, is now used to search for the embedded or the vector data, which gives you more information. Now, this combined information is fetched and passed to the large language model in the last section, which is then fed with a prompt message to give the user a answer back. Now, one of the challenges remain is here too we have you can think about two large language models like two areas of failure where eventually large language models being probabilistic, you eventually have to try it out in terms to see whether you're getting the right areas. So the key question around is how do we test this? How do we enable this retry model? This is where multi-agent frameworks or multi-agents come into expect. Some of the examples of multi-agent frameworks in the area are Creo AI, AutoGen, and there are others also, but these have been a bit, I could say, popular in terms of how companies and organizations and also around the open source frameworking environment. In general, talking about a multi-agent framework, it consists of, you can think about two particular areas where now, if we think about a RAG model or a very general RAG architecture, you can think about that as a single agent, like helping a particular query or a contextual problem. Now, how about having the same problem, but dividing that problem into, or the challenge, into various other aspects, like subdividing it into other very smaller tasks, so that now instead of a single agent, we have multiple agents which are now working on these tasks because they're simpler, they're more focused around a single responsibility principle. If you can think about from a software development environment, now these agents now focus upon these particular single tasks which are more refined, which are more contextual. They can work on this. They are very independent, they are enabled, they work in their separate environments, and they can come back with those solutions where another very centralized kind of a driver large language model takes these responses and collates all the data and gives the response back. So that is where the multi-agent framework, architecture lies in. Just to give you a very brief idea about how Creo AI in general works. So if you think about, there are many AI agents like large language models, and each of them is working kind of has access to tools. Tools can be like you have access to a Python interface or the web search, Google search, where you can make API, requests or do further tasks on it. And each AI agent works through a process layer to enable or handle a particular task and gives an outcome back. Here is an example, if you can see, let's say, and it's a very sample example which you can find in GitHub of Creo AI, where it's kind of a resume finding application. And if you can think about resume writing, it contains variety of skills, right? The very first is you have to write through your skill sets. Second, you have to know what are the market demands. The third is you have to also see what are the job skills which are listed in a particular job description. So, if you think about as a human being, we are donning multiple roles here in order to particularly answer or solve this particular challenge of creating our own resumes. So now, if you see the different agents here, and there have been rules, goals, and kind of a backstory for them, so that they have a contextual area around what they are able to work around. So you can see there's a research agent, writer agent, and a review agent. So these help, kind of the output from one agent go back to another agent, and in the sequence help, formalize and enrich the data so that not only now you have your organizational data, but if you have different aspects of your data, which data is relevant, compare it, and further enrich it. Now this is where we come to the very final layer when we talk about integrating graph with the multi-agent framework. Now, if you see here, the only key component now which is introduced here is the multi-agent framework at the center, which takes control about searching in the graph, getting the data back, and then doing the vector search. But this is not limited to the single process, but eventually it also fetches data from different, because now not only can you do a single graph query, but you can do multiple graph queries, and you have multiple contexts of data from graph, where now this data can be further filtered, enriched, and it can be given more context through prompt engineering, because now you have a particular idea. Let's say it's a customer success chat which we are dealing with, and we know based on the customer, if they have let's say it's more around the payment context. So we have the payment logs, maybe the orders, which we can fetch data around from graph database, for example, Neo4j, and we fetch that data. And now with this data, we have more context around it. So a particular model or an agent does the job of searching that graph query, getting the data, and then further enriching it. And these models can be very important because now if you think about in a multi-agent structure, you not only have text data, but you could also have visual data, like someone getting some image from a particular data store, which could be independent of your current framework. So that multi-structure, including audio, visual plus textual, is what gives the graph layer plus the searching layer from the multi-agent framework a very multi-structured data enriching process, which gives you the confidence to retry it. And also the other key layer which is present here is to have a human in the loop to improve the process around, how can we improve it, because it's two important layers is the prompt engineering, the retry mechanism with the parallelization with multi-agent framework, and the third key aspect which enriches is the knowledge graph network, because graph network helps you to correlate the networks and gives you some very defined data in which you can correlate from multiple mm, touch points. Just a minute. So, so that is a very key element which I wanted to bring into this discussion here. Now, the key aspect when you try this is how do we compare it. Now, there have been a variety of evaluation frameworks where you can do this, but given my personal experience of the open source frameworks and the some of the challenges which I have been driving in my open source work, the principal element which drives more performance and efficiency is the graph network, given its validation. And the second aspect is the multi-agent framework. One of the key questions which happens is where do you have, well, where do you stop? Because as an agent framework, it can retry, as many times. So even if we have a limitless cloud architecture, we have to be cognizant about the cost aspect of it. That is where we need to have a human in the loop feedback mechanism where we take feedback from the user in terms of whether the response was helpful and further fine tune, because I think fine tuning also lays a very important aspect here to gather further structure into a fine tuned small large language models. And the expect here is, even if we started as an industry towards talking about LLM that starts with large language models, we're more focused right now towards small language models, SLMs, which build the overall architecture for your system, which delivers towards kind of a more structured, streamlined, and more data efficient systems. So I think this is the key idea and even the architectural proposition which I wanted to bring through this session. So, given we have still kind of 4 minutes, I would like to thank you all for joining this session. And if there are any questions, I am ready to answer them. So I can take a few questions, and the first one I can think about is Angelo. Based on your experience, what has been the most important early consideration a team should focus on when architecting such solutions? I think the most important is think about your data. I think the right quality data is very important. The second is I think one of the key important areas which I focused upon is even if your data is present, how contextual is the data? Because the same query can have some contextuality in terms of probabilities in different documents. So how do you map the data? Because sometimes when you divide your data, you know truncate your data into different small documents, you leave some of the context. So it's very important to overlap some data. There are different algorithms, as to how do you correlate in terms of vector data. So I think that is a very key aspect as to fine tune your prompt, get your data, and see what are the algorithms you're using in particular to fetch those. Yeah. Mm, so coming to Karen's question, how is the RAG model different from any existing tools like Zapier? Uh, so I think even I think Zapier, I think they are also using some variation of these models, and it all depends upon your data. One of the key aspects is how secure you want your data to be with your organization, because eventually you have to see how Zapier is handling the data. So it's very important how do you deal with it. And even though it's rule based for Zapier, it could be a sequence model, but large language models are more kind of driven through contextual value. And not only is it only probabilistic, but you can bring your own different. I think the only limit is your creativity. Well, with all the tools available, with all the different areas available, you can still bring all these plug in this architecture all together, and experiment with it based on your whole your own contextual independency in your projects. With relation to orders and or line graph, which one should be good to go, even though both work? I think you have to experiment with it. Some of these are, I've seen they have a bit of challenge in terms of your learning, but try them, whichever have examples, which have the best tools available, because you have to again see how independent is it to customize it. If you don't have a particular integration towards it, so that you can, it's all about bringing different tools together. So if the framework allows you to do that along with different examples, documentation, I think that should be a good way to go about it. I'm sorry I may not be able to answer all the questions, but feel free to approach me later, we can connect. But I think thank you everyone for having this great audience.